Welcome to bulletgenie.com. Today we're going to talk about basic operation and setup of the machine. What I've done is plug the machine into a 110 outlet. We've turned the power switch on. We placed the bullet to be tested today, which is a 105 grain 6 millimeter in the cradle, approximately in the center of the bearing surface. We place the motor drive ring onto the bullet, and then we allow it to warm up for a few seconds in this position. What it's doing, it's calibrating to the caliber that we've installed in the bullet cradle. What we'll do at this point, to show you how to fine-tune the machine, I've moved the bullet back toward the ogive just a bit, so that's base to the left. And then we are going to set the coarse adjustment knob. We're on high here. Let's move it down to about the center. There's low. Let's come back to center. There's the center of the target area. Let's go ahead and push test. We're spinning up. Our numbers are 175, 156, 161 with a test deviation of 17. You want that test deviation, the number to the right of the screen up here, to be 6 or less. That's far too high. So what we're going to do is adjust the bullet forward about 40 thousandths, and we're going to do another spin up. It's 30, 29, 28. That's a pretty good test deviation. It's very acceptable. It's a 2.1 with a 29 extreme spread. What we're going to do is move it ahead 40 more. Spin up, analyzing. Okay, we failed because we have not set our coarse adjustment knob to the center of the screen. We're on low because we've been moving the bullet forward. So we must keep that in the center, approximately the center of the screen. Okay, let's do a spin up. 26, 25, 25. That's a test deviation of 1.4. That again is very acceptable. We would put that in a 25 extreme spread bin, which is here. Let's move ahead another 40 thousandths. Now you can use a feeler gauge. I have a feeler gauge at 40 thousandths and 20 thousandths for smaller bullets. I do a lot of bullets, so I just kind of eyeball it. Okay, let's spin up with that new placement of the bullet in the cradle. It's a 26, 26, 27 with a test deviation of 1.4. Okay, this is also a very good test area, a 1.6 test deviation with an extreme spread of 26. So we will go ahead and place this bullet. We're going to call that good. We're going to test in this area. We will put this in a 26 bin, right here, 26 bin. Let's take another bullet. Spin up. 20, 20, 22. Test deviation of 2.1 with an extreme spread of 21. We're going to place this bullet in the 21 bin. We will take another bullet. Spinning up, analyzing. 24, 24, 25. Test deviation of 0.7 for an extreme spread of 24. So we will place this bullet in the 24 bin, which is our longest bin. Now, just for an example, we're going to move this bullet ahead, base even further to the right, another 40 thousandths, and let me show you what happens here. 93, 121, 120 with a test deviation of 28. That's far too high. So what we'll do is, and you can, like I said, you can use a feeler gauge on the 40 side. I've got a 5 and a 35 together. We go so, and bring it back 40, and run another test. 22, 22, 21. A very good test deviation of 1.4 with an extreme spread of 22. So we will place this bullet in the 22 bin. Let's just run another test on it. 23, 22, 22. It's still a 1.4 test deviation, and it's still a 22. So we're going to place this bullet in the 22 bin. And there you have it for this video. There will be more videos to follow. We will be running those very soon.